Welcome to our presentation. In this paper, we try to understand how interest-driven content creation shapes opportunities for informal learning. We present a case study of Novices' usage of data structures in the Scratch online community. In recent years in computing education, there is a focus on computational participation. Learning programming is not limited to classrooms. Students could learn through making and sharing projects in a socially supported context. Many see the potential of interest-driven online communities to promote computational participation. Typically in those communities, users can create and share their works, consume content, as well as interacting with members to exchange feedback and socialize. An overarching question is, how can online communities support computational learning, especially when regarding challenging computational concepts? Some suggest that novices can mentor each other and provide each other with technical social support. Others found that online discussion can be inefficient and often distracted by socialization. The community that we focused on is Scratch, an online community where novices can make and share projects that can be seen, interacted with, and mixed by others. The Scratch online community is built around a block-based programming system that is designed so that each type of blocks is mapped to a specific programming concept. One of the most important but challenging programming concepts for novices is data structure. In Scratch case, data structures consist of scalar variables and lists. Only less than 15% of users have ever used data structures in their projects in Scratch. In this study, we specifically explored if and how interactions in the Scratch community support novices to learn data structures. We designed our study to be a series of mixed method analyses. In our first study, we conducted a qualitative analysis on a sample of discussion threads retrieved from the Scratch forum. The goal is to identify practices in community-generated learning resources about variables and lists. The output of study 1 is a proposed theory. We propose a social feedback loop that describes how community-generated resources may actually constrain innovative computational participation. Then in study 2, we performed a series of quantitative hypothesis testing analysis and found general support for our theory. In study 1, we analyzed the data from the Scratch Q&A forums. We sampled 400 threads in the topic using keywords related to variables and lists and performed quantitative theory analysis. Here are some of our key findings. We found novices in online discussion use specific examples to mentor each other about variables and lists. They learn through the concrete examples they are making, usually specific to games. For example, one user is suggesting others to create a variable for the lives feature for a game. In the other quote, a user is teaching another user to use lists to store armors in inventory, also for a game. As a result, user-generated examples and tutorials are often framed in game-making scenarios. For example, a lot of sample code are games with popular elements like lives and inventory. When users are helping others on issues with variables and lists, they often use examples involving the same popular game elements. While these community-produced learning resources can offer concrete examples, we further found that they may not support everyone's interest. Since most examples are about popular game-related elements, users with different interests may not be able to find useful resources. For example, in this thread, a user asked about how to use variables in their project. Other users offer them examples making score counters in a game. However, the user wanted to use variables in their storytelling project, which is not a game. They ended up never getting help because there's no example in the community. We synthesize our findings as a social feedback loop. Stage 1 suggests that in an online community, some types of creation, we call it use case A, will be more popular than others. When seeking community support, learners will tend to ask questions framed specifically around use case A and use community resources framed in the same use case. Stage 2 shows the result of this process. As learners receive support, they produce new artifacts with use case A that can serve as learning resources for others. Then, users in the future can use these learning resources become even more likely to create the same use case. The output of the feedback loop is that as certain use cases become popular, the community's learning resources are increasingly focused on the same use cases. After proposing a theory from our qualitative insights, we did a second study, a series of quantitative analysis on Scratch data to test our theories. We generated and tested the first two hypotheses focusing on the outcome of the social feedback loop. First, we hypothesized that certain genres of projects involving data structures will become more popular over time. Specifically, over time, more and more projects involving variables and lists in the community will be games. We tested the hypothesis using logistic regression on the odds of project being game over time. For all the hypotheses, we conducted analysis on projects with variables and projects with lists, respectively. The first hypothesis is partially supported by projects with lists. Over the years, the proportion of projects with lists has been increasing in the community. Second, we hypothesized that the names that users gave to variables and lists will become more concentrated over time. We measure concentration using Gini coefficient of the counts of variables and list names in the community. We tested the hypothesis using linear regression of Gini coefficients over time, and we found general support for this hypothesis. In addition to testing the outcome, in our third hypothesis, we tested the mechanism of the loop. We speculate that users exposed to popular use cases will create similar artifacts. Therefore, we hypothesize that users who have been exposed to projects involving popular variable and list names will be more likely to use those names in their own projects. We measure exposure using whether the user has downloaded projects with popular variables and list names. With our survival analysis, we found partial support for projects with lists. Users who have been exposed to popular list names, represented by the solid line in the figure, will be more likely to use, in other words, less likely to never use, popular names in their projects, compared to users who have never downloaded projects with popular list names, represented by the dashed line. In summary, our findings suggest that online communities, novices are able to mentor each other using concrete examples that support common interest. However, additional regulation and supports, as listed below, need to be implemented so that it could mitigate the effect of the social feedback loop that we discovered in our analysis. Please see our full paper for the full set of findings and insights. Thanks for listening.